Hello everyone, welcome to the another very important session in which I'll be discussing some more important questions and the concepts of quantum mechanics. So I hope that the discussion which we will be doing today in this session will be getting clear to all of you. But in case if anywhere anybody will be having any doubt, you can surely let me know about it. We will try to consider those points then. Also guys, one more thing here I would like to tell you, that is regarding the 7 days free trial. Hello Anshu, hello Vinash, hello everyone. That's going to be the steps you can follow to get your 7-day free trial. So what are the steps you have to follow? I'm just going to show you quickly. So first of all, you have to enter your phone number, okay? Then you have to enter your OTP to verify your phone number. Then you have to select your target exam. So here we are gonna have the another one, that is the activation code you have to enter, and then download the Unacademy like learning app or app to start your preparation. Okay, so that's how guys, this is how you will be able to get your 7 days free trial. Give me a second. Give me a second, guys. So yeah, after considering this part, we are going to talk about the another important slide, which is regarding the Unacademy Plus Iconic and the Lite subscription. And then we will be considering the like, if you want to start your preparation under the guidance of top educators and you don't want to miss out the important points, important topics, questions, concepts, tips and tricks, you can take your subscription, whatever you think will be working better for you. Also guys, you can use and apply the code Anjali Alive to get the discount in the total subscription amount. Clear? So I hope each and everything is clear till this point to everyone. And one more thing, even now the important notes are available on the learning app, which will be helping you to take out the important topics, concepts and every important thing, which will be helping you to take your preparation to a very good level. Here we are having the slides regarding the Unacademy learning app. This is about the session. This is something about me. This is about the community feature we are having on Unacademy, and that's something guys which will help you to stay updated and to know about the important things. Okay, so this is all about the session. Now we are good to start our discussion for the important questions and the concepts. So I will start taking the important questions right now. I'll write the first question. If there is something you want to share guys, you can even mention in terms of the topics you want to consider and anything like that. Very good evening, Snehashish. Hello, Shantnu. Okay, Shantnu. Okay, guys. So what we are going to do, we will take the questions from different topics and concepts, not just from one particular topic or one particular type of question. So you will get to know about many concepts, many important points and all that part. Let's take it then. Options are L square and LZ is the last one. Just say whatever you think is going to be the correct one according to you guys. Mention it in the comments, the right option, and then we can talk about it if in case it needs to be discussed. So I'm just going to wait for your reply. Very good, Shantanu. That's great. But I would like to explain it then. Okay, have a look at this part. They have given you the wave function, right? Which is psi NLM. And in this case, the wave function psi, which is that wave function, is an eigenfunction only of what? So in this case, guys, eigenfunction means that when you are applying or operating, for example, Hamiltonian, okay, no, you don't have to normalize it, or the L square or LZ. So your wave function should remain same. For example, I am applying any operator O or A on some state psi, and it gives me a constant here, which is my eigenvalue and the psi as it is. So that means my function should not get changed, right? So same wave here, I'll apply the H as the Hamiltonian on this wave function. So H is what? H represents the total energy of the system, and it depends on the n value. If somebody is there who is still confused like how H is related to n, so I would say you can think about the energy of the hydrogen atom. So what is the nth state energy of the hydrogen atom? So that's going to be negative 13.6 over n square. Okay, so depending on the different n values, are they have different n values or same? So if you will see, n value is same for all the three terms, which is 2, 2, 2, 2, 2, right? And will it be making any difference in the wave function terms even if you are taking the energy of any specific case? So that means these terms will still be there in your wave function. They are not going to get changed, right? And that means it is the eigenfunction for the Hamiltonian. What about the L square and LZ? Let's go for L square. So when I'll consider the L square, guys, it will give me L times L plus 1 H gut. Now I just have to see that this term should not become 0 anyway for all the L values present there. So if I will see the L values to be there, you can have a look at this part that here L is equal to 1, L is equal to 1 and L is equal to 1, which means that this value is not becoming 0 anytime for all the three terms in the wave function. Other than that, if I will talk about LZ now, very good Ritik, but I'm just going to explain it once quickly. So for LZ, let's take another color here. LZ, when you operate on some state, it gives you MH cut, right? So MH cut. But if you will see M here, we had was 0. Here minus 1. Here plus 1. So if I will plug in this 0 to be here, it will give me this value to be 0 completely. And that means this term will not be in the final expression. That's making change in our wave function. Hence, for LZ, it is not an eigenfunction because the wave function is not remaining same and it is going to get changed. So it is the eigenfunction only for H and L square. Hence, our option C is the correct option. Please tell me, does it make sense to everyone? And everybody is going to get that option C should be correct. Reason, because of LZ. L2, L square part. Okay. For the L square, you always have to take what? L times L plus 1. That is the only eigenvalue you are going to get, right? So if I will see the L square, it's not making any of the coefficients of the function for any state to be 0. Is it making 0? No. Why? Because L is 1 in all the three cases. So when L is 1 in all the three cases, if I will plug in L is equal to 1 in that expression, that is going to give me 1 times 1 plus 1, which is going to be 2h cut square, right? And 2h cut square, when you will multiply with any term, at least all the terms will still be there, and that's not going to get changed. Snehashish, does it make sense? So you just have to multiply this value with all the terms. And our main purpose was just to look at this thing, that the terms should be existing even after operating the specific operator like L square, LZ, whatever, right? So it's already there. Does it make sense, Snehashish? And if you have a confusion regarding any such part, that how it's taking place, anything like that, you can ask it. I'll just try to make it clear. Okay, guys. So your right answer is option C. Yeah, no change in the wave function. Means, see, no change doesn't mean any constant is not gonna get multiplied. Constant may get multiplied, but the wave function terms sine 210, sine 21 minus 1, sine 211, all three are still existing after operating that L square operator too, which means no change, right? The wave function terms and the states. So it is also the eigenfunction for L square. Any question anybody is having even now, guys? If yes, just mention it. If no, I'll take the next question then. Tell me. If there is any doubt anybody is having. Otherwise, I'm ready with the next question. So I'm just going to write it on the next slide. Three sine 211. 3 sine 211 or 211. I'll write it again. Then you're gonna have sine 210. Then you are gonna have root 15 sine 1 minus 1. And options are 39 h square over 25, 13 h square over 35, 2h square, 26h square over 25. Try it now and let me know whatever you think is the correct answer. Very good, Snehashish. I will let you know whether it's correct or not. We will also be doing the discussion about it, but till that time, I would like to say, okay, just have a look at the steps and the approach you followed. Otherwise, I'm gonna start the discussion in just little bit time because I'm waiting for everyone to complete it, giving time for everyone. Like they can try to work on it, and if they will have difficulty, we are gonna start the discussion then. So, hello Aturv. Okay, so if I'm going to talk about this question, guys, what they're asking you to find, they're asking you to find Lx square plus Ly square, right? The expectation value of this. So what you will do, because you know we don't directly find the expectation value of Lx square plus Ly square, while you know about it, Lz and L are so much popular in the common one. So what we try to do, we try to change them in the terms of L and Lz. But how you will be doing it, let me just show you the steps. L square can be considered as equal to Lx square plus Ly square plus Lz square, right? Then Lx square plus Ly square will be taken as equal to L square minus Lz square. For all terms containing L square, like when you operate it on some state, very good Shantanu, that's correct. So it will give you L times L plus 1. Oh, I made T, not T, it's just L. Okay, so L times L plus 1 h square and minus m square h square, right? Because Lz gives you m h. So I have just done the square of these two. Once you will simplify this part, like just by plugging in the values you are having in the expression, you will be able to get your final answer. So it's going to give you, just see the terms present in the expression and just try to plug in the values. You can either find out the L times L plus 1 h square separately, m h square separately, and then you can subtract those values, or it's up to you. If you are comfortable, you can do it directly. Snehashish, just check the values here and tell me, are you able to get option D now, or are you still getting option B? I'll wait for your reply, and for everyone, just check it out and tell me whether it is clear or not. Okay, I'm gonna wait for your reply then, or otherwise I'll take the next question once it will be clear to everyone. Let me know, let me know, let me know as you will get it done. It's okay, Snehashish. So, see, did you understand this part, Snehashish, that you are getting Lx square plus Ly square is equal to L square minus Lz square? Does it make sense? Right? Now, when you want to find the expectation value of these two, you can also equate it with this. Means either you can work on this side. So, L square means L times L plus 1 h square. So what is the L here? That's 1. NLM, 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 right? So L in all the three cases is what? 1. So L times L plus 1 will be what? And when you are finding the expectation value, do you know this formula? Expectation value of any operator A, if you find it with the help of eigenvalue, so it will be summation over n a n p n. P is the probability of finding the particle in that state. And how we find the probability? That's going to be its particular state coefficient is square, okay, divided by sum of square of all the coefficients we are having in that particular wave function. So that gives you the probability. Now let's work on this part. So probability of finding the particle in first state is 3 square over 5 square, the coefficient square, divided by the sum of square of all the coefficients. So when you will take that, 3 3s are 9 over 25. Okay, I'm just checking out is it normalized or not. Now next thing is it's going to be, yeah, square is there, 1 over 25, right? Plus 15 over 25. So if I'm going to check it out, it's giving me what? 25 over 25 after adding, which means it's just a normalized wave function. The sum of square of all the coefficients is what? 1. Hence it is normalized wave function. So when it is normalized, to find the probability, I just need to write the particular state coefficient square to find its respective probability. So which will be 9 upon 25, 1 upon 25 and 15 upon 25. Okay, which is 1. But tell me one more thing, L times L plus 1, will it be 1 times 1 plus 1? And that's to 3 terms added together, right? So what I'll get there? 3 times L plus 1, which is 1 plus 1 h cut square. Does it make sense? And everybody is getting it same? Because I had the same L value, so I just wrote it in general. Does it make sense to everyone? Okay. Okay. If it's not getting clear to anyone, just let me know. Now, what I'm going to do next, I'll be having for all the 3 states. But guys, 3 states are there, that's true. But if you will take their coefficients inside, let me just write separately to show you all the steps. L times L plus 1 h cut square for the first one, which is giving you the probability as 9 over 25. For the second one, 1 times 1 plus 1 h cut square, which will give you 1 over 25 as per its coefficient, plus 1 times 1 plus 1 h cut square, which will give you 15 over 25. So when you take 1 times 1 plus 1, which means 2 h cut square common, all the terms added together gives you 25 over 25, which is 1. Hence you are getting just 2 h cut square, right? Once you got 2 h cut square as the expectation value of L square, what about the expectation value of Lz square? Let's do it as well. So this first case will be mh cut square, m square h cut square, which is just 1 h cut square. Okay, and its probability is 9 over 25 plus. Second one will give you NLM 0 because its m value 0 plus. The third one gives you negative 1 square over like the negative 1 square and h cut square, which is again 1 h cut square, and then you are having 15 over 25, right? Now when you will simplify it, 15 and 9 is what? That's going to be your 24, I think. Yep, 24 over 25 h cut square. Any doubt to anyone? If yes, let me know. So it gives you L square minus Lz square is equal to what? L square you got as 2 h cut square, and you got the Lz square as 24 over 25 h cut square. Please let me know. Is this all right and clear? So once you got this part, when you will simplify it, you will get 50 minus 24 over 25 h cut square common. And when you are simplifying it, 26 over 25 h cut square you will get. That's your option D, which is the correct one. Please let me know if there is still any doubt anybody will have. We will talk about it. But if everything is clear, that's great. That's great. I'll write the next one then, guys. Options are try it now and let me know as you will get it done. And guys, let me just tell you one thing here. Like any subject you are doing the preparation for, it can be quantum, classical, condensed matter, okay, nuclear, EMT, electronics, any subject. Just remember one thing, it's not like no subject is difficult, okay? Every subject is quite easy, but the only thing is how we are trying to complete it, trying to cover it up, trying to understand it. Our approach is the one most important thing which will either make the subject to be difficult for us or will make it easy for us. So we are the one who is gonna make it or find it how we are just proceeding further. So I would say whatever you find best. If you find best like you want to cover up the topic first, then you want to go over the questions, that's too okay. If you want to go over the formulae and just to understand like okay, what formula have what expression in it, what term, particular term which is present there has its meaning, and then by understanding that part, then you can start working on questions too. Okay, it's your choice and it's your approach, because I know sometimes we are not gonna have enough time to spend to do the preparation of any topic or any subject. So you, that different approach may even work for you. So it's your choice. Either go for the details of the topics and then start the question, go for the facts and the formula of the topics and then start the questions. Do the previous year questions as many number of times as you can. Okay, so revision will be the one thing which will make you prepared and ready for solving and working on any such type of question. So that's what you need to know and you need to consider. I know Snehashish, but as you will increase the number of times you are doing the revision, that will be making it easy for you to understand and that will be making it like you more confident. So the main thing is revision. Keep on doing as many number of times as it is possible for you to do. Okay, very good, Preeti. That's correct. That's great. You got it right. So actually here they are asking you to find the probability for finding the particle in the interval between negative a by 2 and the positive a by 2. So if I'm going to talk about this one, what it gives you integration negative a by 2 to positive a by 2, and that's going to be your the wave function you have to consider here, because you are finding the probability to find the particle in the interval for the given system. So that is the symmetric potential well. Symmetric potential well means root 2 by 2a, because length of the box is 2a, and in this case sine or cos. So since we are talking about ground state which is having n is equal to 1 value which is odd, so even function, which means cos should be there. So cos n pi x over a is 2a in this case, and then again same wave function we will have. Just we have to solve this integration and we are gonna get the answer. Very good, Snehashish. That's great. Yeah, that's correct too. You just have to solve this integration, guys, and you are reaching to your final answer. That's it. Okay. If still anybody is there having any doubt, something you are not able to understand or you are not getting, you can tell me. But if it is clear, I'm going to write the next question then. the composite wave function for the system with total error G is equal to 5 pi square h square over 2 ma square is, options are 2 by a sine pi x1 by a sine 2 by x2 by a sine 2 pi x1 by a sine pi x2 by a two by a sine pi x1 by a sine 2 pi x2 by a plus sine 2 pi x1 by a sine pi x2 by a. Option C says 2 by a sine pi x1 by a sine 3 pi x2 by a 28 minus sine 3 pi x1 by a 2a here sine pi x2 over a. Okay, next slide now. Here we are gonna have the option D only, which is gonna say 2 by a sine pi x1 by a. Next we are gonna have is cos pi x2 by a. Next minus sine pi x2 by a and cos pi x2 by a. Try it now and let me know as you will get it done, and whatever is the right answer according to you, just mention it in the comments. What do you think? Is it option A, B, C or D? Give me a second, let me just make it properly. Okay, consider it, guys. Whichever you think is the correct one, you can tell me. And if you're not able to get it, it's okay. I will help you then. Here are the options, guys. Okay, guys, even let me just tell you here, if you are having the doubt in this part, first of all, you will observe the system given to you, okay? And if there are a number of particles, you also have to consider that. So, two fermions they are talking about, and the system is infinite square potential. So, in this case, what will happen? If you are going to consider two particles, infinite square potential, how you can get the energy to be 5? So, nx square plus ny square, which is going to be, if one particle is in the ground state, which is n is equal to 1, and another one is in the n is equal to 2 state, pi square h square over 2ma square, right? So in this case, 1 and 2 square will give you 5, 5 pi square h square over 2ma square. So that will give you 1 and 2 as your nx and ny value, and you will get option, let me just see, 1 2 to 1. Okay, option A to be correct. Why? Because you are going to have the sign n pi x1 over a. So initially you have taken nx to be 1 and ny to be 2, then 2 1. This is how you're just going to get it, 1 2 minus 2 1. So that's how you are getting your final answer to be option A. Remember, for fermions, you are having the wave function which is asymmetric in nature. So when the wave function is asymmetric in nature, you get it in the form like how we are discussing about that, psi 1, psi 2 minus psi 2, psi 1. And even x1, x2 have been interchanged. Okay, so your option A is the correct one. You can tell me if there was any doubt. If it is clear, we will take the next question then. Try it now, guys. Whatever is the right answer according to you, you can just mention it. Otherwise, I will let you know if you don't know what is exactly the right answer. So guys, basically in this case, they have initially given you the wave function, which is 1 over root 2. I'm not getting your comments. Okay. 1 over root 2 phi naught plus iota phi 1. And here when you want to find the expectation value of the Hamiltonian in the state psi, so what it will be? It will be your E1, P1. Okay, P is the probability plus E2, P2, right? Okay, very good, Snehashish, but there is a mistake. And it's okay you made that mistake, but focus on where is the mistake and what is the mistake. First of all, if you are anytime writing the probability, so energies they have given you for phi naught, it's E naught. What about the probability? It will be 1 over root 2 square and it's mod. Always take that mod there. If you're missing that mod, your answer is going to be wrong. Coefficient of both the terms is square, and their mod. Then plus E1 iota square and its mod divided by 1 over root 2 square and its mod plus iota square and its mod. When you find the probability, in every term after even taking its square, you have to take the mod. So that's going to be E naught over 2 over, it's 1 over 2 plus 1, which is 3 by 2 plus E1 divided by 3 by 2, which will give you 2 to cancelled out here. It will give you 2 by 3, E naught plus 2 E1 over 3. E naught plus 2 E1 over 3, which is option D. So mostly students make this mistake. They get the negative sign just because they don't take the mod after considering the square in each term in the probability case. Does it make sense to everyone now? If still there is doubt, you can tell me. But if you are getting to know about it right now, that's great. Be careful about that part and never ever make this mistake. Okay, I'll be giving you the next question now, guys. Like, these are little things, but they matter a lot. They can be responsible for making any questions answer right or wrong. Okay, next one. Wave function now. Very good, Binod. That's correct. So, guys, you can try it now and let me know whatever you think is the right answer according to you. You will be mentioning it. So, let me know which option is correct according to you for this question. Otherwise, I will be starting the discussion and will tell you what steps you need to take, how you need to proceed further, all that. Very good, Snehashish. Okay, I will even be explaining it. So let's wait for others' reply too. It is basically the half harmonic oscillator, not the normal harmonic oscillator. So when it is the half harmonic oscillator, it's going to be, see, its energy expression is n plus half h cut omega. But for the half harmonic oscillator, which is also known as truncated harmonic oscillator, n values will be starting from 1 and only the odd values of n you will keep on taking 1, 3, 5. Like for the normal harmonic oscillator, you take n plus half h squared omega, but you take 0, 1, 2, 3 and so on too. But for the half harmonic oscillator, you just take the odd values, right? Now once you take that part, now you have to write the expectation value of energy. So I'll have to consider E naught P naught plus E1 P1. But actually the E naught will have the n is equal to 1 associated energy and E1 will have the n is equal to 3 associated energy. So that's the difference, and the probabilities, you can see it is also the normalized wave function. So 1 over 5 plus 4 over 5, which is going to be your 5 over 5. So it will give you 1 over 5 SP naught, n is equal to 1 will give you 3 by 2 h squared omega, and n is equal to 3 will give you 7 by 2 h squared omega, and P1 is 4 by 5. So that's how you're just going to find it. So what you are getting, 3 by 2 h squared omega times 1 by 5 plus, next you're going to have is 7 by 2 h squared omega times 4 over 5. So 4 7s are 28 plus 3, 31, 31 over 10. That's your option D, which is the correct one. Let me know if in case there was any doubt. Done? Done, 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 done. Clear? Okay, great. Now let's try to take one more question, and that may be our last question for today's session. Okay, so just one more. Let's take this one. This is basically a trick based question I'm going to take right now. So if there is someone who doesn't know about the trick, they will get to know with this question. Excuse me. state of the oscillator. In units of h squared over m omega is, options are 2.5, 1.5, 6.3, 3.4. Try it now and let me know whatever you think is the correct answer. No, Vinod. For this month, I almost conducted all the sessions here. Like, I'll just have one more session, which is tomorrow morning, and that's it. Like, for this month, I had so many sessions till now, okay? But now we may not have after this session. So, only one session I will have, I think, and that's tomorrow morning. Tell me what is the right answer here. If you will have any doubt, you can let me know. Yeah. Very good, Snehashish. That's great. But I have to tell you something regarding this. So I'll be starting the discussion too. Let's see if anybody else want to reply regarding this question's answer. What is the correct option according to them? Okay, even I'm starting the discussion about the trick. So actually, guys, for the harmonic oscillator, if you want to find the expectation value of position square, right, then you have to take n plus half h cut over m omega. And if you want to take momentum square expectation value, it will be n plus half h squared m omega. Okay, in case of momentum square, it's h squared m omega is multiplied, because we also know momentum in general is mv. So same way we are having here. For position square, it's h squared over m omega, but both have n plus half in them. So if I have to find the expectation value of r square can be taken as x square plus y square plus z square. I will write the expectation value of r square as nx plus half h squared m omega, h squared over m omega, because it's position, not multiplied m omega, plus ny plus half h squared over m omega divided plus nz plus half h squared over m omega. That's what you are going to have, right? Now, if we will talk about the expectation value of r square, in this case, you are simply going to find this expectation value corresponding to the first excited state. So, what is going to be the ground state nx, ny, nz 0, 0, 0. First excited state 1, 0, 0, 0, 1, 0, 0, 0, 1, right? So, when you are going to consider first excited state, plug in 1, 0, 0. 1, when you will plug in here, 3 by 2 h squared over m omega, 1 by 2 h squared over m omega, 1 by 2 h squared over m omega. So 3 plus 1 plus 1, that's 4, 5. 5 by 2 h squared over m omega, which is 2.5. Hence option A is the correct one. Please tell me, does it make sense to everyone? And is this clear to everyone now? If yes, that's great. So your right answer is option A. Now you can see the little things, okay, whichever are gonna make it wrong, or which are gonna be making it right if you will take care of those parts, right? So let me know if still there is anybody having any doubt. Okay, guys, I hope everything we have talked about today in the session is getting clear to everyone. So let's keep it this much today in this session. And thank you so much everyone for joining this session. Even if there is someone like who wants to join the courses by the top educators on Unacademy, if you don't want to miss them by the other top educators we are having on Unacademy, okay, so you can take your Unacademy Plus or Iconic subscription. You can also use and apply the code Anjali A Live as mentioned here on the screen. Even the important notes which are now available on the learning app, you will be able to check them out too. Thank you so much everyone for joining the session and for attending it till the end. Thank you so much everyone. Thank you. Bye. Take care.